Hi all, we start with new topic, that is BCNF, voice code normal form. Okay, so already we have studied 1NF, 2NF, 3NF. So it's almost same type as that of 3NF. BCNF is almost same as the 3NF, but a little bit stricter than the 3NF. Okay, so in 3NF we had definition as a, if any functional dependency X may be a standard key or A should be a prime attribute. Okay, so this was there. Any one you have to, should be there. That is, X may be a super key or A should be a prime attribute. Okay, any one should be there. Okay. Now in BCNF we say that this is a if any functional dependency X to A is there, means X should be always super key only. So our option whatever we had, that is like A should be a prime attribute, that is removed. So this is a little bit stricter version of okay, 3NF. Okay, so everything remains same, that is to be in BCNF, R should be in 2NF then, okay, or 3NF then, and this is a new thing, it should be there X to A. If any dependency is there, then X should be a super key. Okay, so we'll see one example. Okay, so here, okay, so property ID, okay, country name, lot number, okay, so then area. Okay, so suppose four attributes you have, okay, and property ID is a candidate key, and these two also together is a candidate key, that is country name and lot number together is a candidate key. Okay, so that's why you have FDSA from these two. Okay, area we can derive, or we can derive the property ID. Okay, and here from property ID we can derive all the things. So here these two together is a candidate key, and here only property ID is the candidate key. So total two candidate keys are there. This is the first one is a property ID. Okay, so second one is okay, so first one is property ID, second one is candidate name and lot number together is a candidate key. Okay, so that's why we have these two FDs, FD1 and FD2, and one more FD is given as a area can derive, that is country name. Okay, so from area we can derive the country name. This is the FD we have. Okay, so if you saw here from FD1, that is FD1 is a X. Okay, so these all are part of A. Okay, that is X to A, whatever we'll say it. So here property ID is a X, so remaining all attributes together I can say as a A. Okay, so X to A is there, so X should be a super key. Okay, so since it's a primary key, so we can say this one is a super key also. Okay, so and here one more second FD. So country name and lot both together you can derive area and property ID. Okay, so here X is these two attributes together. Okay, and A is area and property ID. Okay, so these two together. Okay, so here X, if you saw, this is a candidate key. Okay, so these two together is a candidate key, so you can say as this is a super key also. Okay, so this FD also don't have any problem. Okay, now we'll say last one, that is FD5, area to country name. Okay, so area, this is my X, country name is a. Okay, so here X is nothing but area, so is it a super key? No. Okay, because this from this key we can't derive the remaining all attributes. Okay, so if it is a super key, we have to derive all the attributes from in a that table. Okay, so we can't derive all the attributes, only it's deriving the country name. Okay, so remaining two attributes we can't derive it, so this is not a super key. So this gives the problem. Okay, so this FD we have to remove it. So FD5 we have to remove it. So what we will do is the remaining three will keep same thing, that is property ID. Okay, so then area, then lot we're keeping in one table. Okay, then country name and area, these two were keeping in one more table. Okay, so that's here property ID, lot, then area, so these three were keeping in same thing. So from here whatever FD5 whatever was there is the country name, so country name we removed, for that reference is area. Okay, so here this will become a primary key. Okay, and here this will become a foreign key, which refers here. Okay, so this is the primary key foreign key concept will happen. Okay, So this is my actually overall whatever we have. This is there in BCNF. Okay. Okay. So here just one example. Okay. One more example is there. So here A, B, C, three attributes are there. Okay, so and A, B both together is a primary key. A, B to C we have. Okay, so here A, B to C is thing, but here we have this one FD that is a primary key to one non-prime attribute we are deriving it. Okay, so this is a given one. Then along with one more FD is given as a C to B. Okay, so C to B. So here if you saw, this is there in 3NF. Okay, so we don't have any partial dependency. Okay, so and 3NF is a transitive dependency. AB to C is there, C to A is there, but it is not dependent on primary key. Okay, so this is also partial 3NF, it's already there. Okay, or you can say as a X to A. Okay, so whenever we are saying X to A should be a prime attribute or X should be a super key. So here if you saw for FD2, my C is nothing but it will become as X. Is it a super key? No. Okay, but B is a prime attribute because it is a part of our primary key. So it's a prime attribute. Okay, so we don't have any problem with that one also. So it's there in 3NF. But is it there in BCNF? So if you saw this X is a whatever means C to B, whatever this FD is there here, this is my X, so it's not a super key. So this is not there in BCNF. Okay, so can we decompose this one? Okay, so for that some examples are given. Okay, so here student name. Okay, so it can be there as these two together. It's the student and course. Now together they can choose the instructor. Okay, so instructor can have the references to the courses. Okay, so this is the whatever three same whatever A B C we take it, for that same thing is given. So here this is FD1, FD2, same thing. Okay, so this is there in 3NF but not there in BCNF. So relation not there in BCNF should be decomposed so that as that meet the property. Okay, so while decomposing, so one algorithm is there, that is a functional dependencies whatever will that how you have to decompose it. Okay, so that algorithm also will study it. Okay, so that algorithm 11.3 is there, so that will study it. Okay, so while decomposing this one, so straight away directly we can't decompose it. So here what we will do is, so we have to divide this one. Okay, student, course and instructor whatever we had. Okay, so this one we have to divide into two things, that is student instructor. Okay, then course instructor, then course instructor and course. Okay, so like this we can divide into different three things. Okay, so this combination, so whatever it was there, so here in all the three tables all will become the primary key. All attributes means this is a combination of student and course will become the primary key. Course and student instructor and student, that is also will become the primary key. And course and instructor, that also will become the course and instructor, that also will become the primary key. So all will become the primary keys here. So now next we will go for multivalued dependency. Okay, and fourth normal form. Okay, so before going for what is fourth normal form, just we'll study about what is multivalued dependency. Okay, so already we know what is multivalued. Okay, so here something, but one attribute can have more than one values, so that is multivalued. Okay, so what will happen is normally we will not get the actually in one NF those are not allowed. Okay, so it's multivalued dependencies, multivalued attributes are not allowed in one NF. But suppose our table contain, so what we are doing it in that time, if it is in not multivalued dependencies, sorry, if you have a multivalued attribute in our table, so you should divide it. Okay, if you remember in one NF we should divide it, we used to make a different column for each of the attribute. Okay, so then we used to keep the all the values. Okay, so suppose more than one attribute is there. Okay, so dividing the table and keeping it repeated values will be a headache for us actually. Okay, so that time it's not a straightforward task to how to divide it. Okay, so that we'll see it. Okay, so here if you saw here, let's go. This is the first table. Okay, so e name, okay, then p name, then d name. Okay, so here employee name is there and which project he is working, that p name is there, then who is the dependent on him, okay, that is there. Okay, so this is the p name is a multi-valued and d name is a multi-valued, means in this one employee can work on more than one project. Here x and y he is working, and one employee can have more than one dependencies. Okay, so here one employee can have, this is nothing but he is working on sorry, he have the dependency as a John and Anna. Okay, so two people are there. Okay, so this is repeated values, so we are trying to keep it. So all three attributes together is a my primary key here. Okay, so in this all three together is a primary key. So what is multiple dependency? We will say, suppose we have as a uh, any relation. Okay, sorry, any fd. Okay, so in that x to y. Okay, so this is x. Okay, then this is y, consider it. Okay, so x and y, so x to y, so y is a multivalued attribute, and there is a one more thing, that is z. Okay, so there is not a subset of these two together. Okay, so x and y not together, no, it's a subset, no, not a subset of these two together. So that z also is there. So this is independent of y. Okay, so this is y is there here, and this is z, whatever we are saying. So this should be independent of y. So if you saw here in this example, p name is independent of dependent name. Okay, so p name is nothing but a project. So this employee is working on any project. Okay, so this attribute is independent of dependent. Okay, so he is not at all dependent on the whichever project this employee is working on. These two attributes are not at all related to each other. Okay, so if like this anything is there, so that will say as a multivalued attributes. Okay, so just we'll see one definition properly. Okay, so or you can say as a, there is a relation. Okay, so independent relation 1 is to n. Okay, so here 1 is to n relation is there, because n means is the multi-valued attribute will come. Okay, so one employee, more number of values will come. Okay, so minimum two independent 1 is to n relationship will come, that is a to b, this a to b, these two, then a to c, then a to c. Okay, a to c, and these two are independent. Okay, this is also employee and project name. Okay, this is a one relation, and it is not at all dependent on employee to dependent name. Okay, so both relations are independent. Okay, that is a to b and a to c. So a is common, that is the employee is common. Okay, so then relation r will say as a, this is there in multi-valued dependency, may arise multi-valued dependency. So whatever these things will be, there's this entire thing r who has the multi-valued dependency. So how this is a formal definition will say is, this is a multivalued dependency x. This is a double arrow. Okay, there's a multivalued dependency. The normal dependency will show as a one arrow only. Here two arrows will be there. Okay, so double arrow with y. Okay, uh, multivalued dependency with y. Okay, so here multivalued dependency x to y specified on a relation schema R. Okay, where x and y both are subset of R. Okay, so this is my entire thing, this is entire R. So x, this is a subset of R. Okay, y also subset of R. Okay, then specifies the following constraint on a relation state R. Okay, relation state, so relation state means some values you have it. So inside that, if I took one row, that is a small letter r. Okay, so relation state r. Okay, so of r, capital R. So in this entire thing, whatever table is there, this is of r. Okay, so if there are two tables t1 and t2, okay, sorry, two tuples t1 and t2, okay, exist in r. So in this we have two tuples. So in the t1 and t2, okay, two tuples is considered as a first one and second one. Okay, no, t1, this is the first row is a t1, second row is a t2, and the two tuples such that t1 of x
is equal to T2 of x. Okay, so if we are saying is these two are equal, T1 of x is equal to T2 of x, then two more tuples will be there. Okay, so that is T3 and T4. Okay, so now what we'll say is here relation R is there, so we have at least three attributes x, y, okay, and z. Okay, so what is z, we'll see it. So here x and y, two attributes will be there. Okay, so x and y both are subset of R. Okay, and if there are two tuples, there is a T1 and T2, and these x values are same, means there will be two more tuples will be there, that is T3 and T4. Okay, and which have the some property. Okay, what is that property is nothing but here that time T1, T3 of x is equal to T4 of x, and it is equal to T1 of x equal to T2 of x, means all these four rows will for x will be the same values. Okay, so this is the same value we have it. Okay, then T3 of y is equal to T1 of y. Okay, so T3 of y, so here third row T3 of y is equal to T1 of y. So this one, so this column is y. Okay, so in that this x value and this x value project name. Okay, so x project name, here x project name, these two will be same, and T4 of y and T2 of y will be same. So here y project name and here y project name, that is a T2 of y and T4 of y, both will be same. Okay, so and T3 of z. Okay, so what is z is, so z equal to R minus x union y. Okay, so here x union y, whatever will be their attributes. So we have two attributes here. Here this is x, this is y. So union these two minus we have to do it in R. Okay, so that is R minus x union y. So this will come whatever remaining all attributes. Okay, so now here we have three only. If it is a fourth attribute is there, that also is a part of our z. Okay, so here this attribute will be the z. Okay, so that is my z. Okay, so here that time T3 of z is equal to T2 of z. Okay, so if we have condition as a here T3 and T1, okay, so that time here for z it will come as a T3 and T2. Okay, so here T3 and T2, these two, Anna. Okay, so these two will be same, and T4 equal to T1. So T4 of z is equal to T1 of z. T1 of z and T4 of z, these will be equal. So if I changed this one, okay, so if I made this one as a z and this one as a y, so then also it will become as a true only. Okay, that is employee and dependent name. Okay, so this one if I made as a one relation, and this is that time project name will become as a my z. So, okay, so that is a just a row number will change it. So you can insert a row in the same manner or in a different order. Okay, so here T1 will become T2, T3, T4, whatever, this order will be changed. Okay, so irrespective of that one, so these conditions will be true only. Okay, so this logic will remain same, so this condition will be true. So whenever we will be having this property, so we are saying as a we have the multivariate dependency. So here we are saying as a, we have the multivariate dependency among the attributes of R. Okay, so here that is with respect to x, y, and z, three kinds of attributes. Okay, and the x, y, and z, all three are the set of attributes. So here you can have a one attribute or more than one attribute. Now we took example for each, that x, y, and z, one attribute only. Okay, so this is multivariate dependency. Okay, so now one more thing we'll study, that is what is trivial multivariate dependency, okay, and non-trivial multivariate dependency. Okay, so here if I have as a x to y, okay, multivariate dependency. Okay, so then y is a subset of x, or x union y is equal to R. Okay, so x and y both together, if it is my entire R is there, or y is a subset of x, means this is a trivial dependency. Otherwise we'll say as a this is a non-trivial dependency. So here if you saw this one, so is it a trivial or non-trivial? So if I consider this one as a x, this one as a y. Okay, so here x union y both together is not my R. Okay, and here this is y we are considering, so it's a not a subset of my x. Okay, so this whatever we are considering this table, there's a non-trivial multivariate dependency. Okay, this is a non-trivial multivariate dependency. Okay, now we'll see what is 4NF. Okay, so depending on this one, 4NF is there. Okay, so what is 4NF is, so here we are saying as a in 4NF there is a relation. Okay, R is in 4NF with respect to the set of dependencies F. Okay, so in this F now we are saying as it is not only functional dependency, here we have a multivalue dependency also. Okay, so both together my F is there. Okay, so if set of functional dependency F is there, okay, if every non-trivial multivalue dependency x to y, okay, so there may be more number of functional dependencies or multivalue dependencies. Okay, so we will be having for all non-trivial functional dependency x to y. Okay, so that time x should be a super key. Okay, if in my table, given table, I have the multivalue dependency that is x to y, then x should be a always super key. Okay, this is the condition. Then we'll say as a this is there in 4NF, otherwise it is not there in 4NF. Okay, so now we'll see this is there in 4NF or not. Okay, so here my I'm considering this one first column as a x, second column as a y. Okay, so x to y I have the multivalue dependency. Okay, so this is there, and if I consider as this one to last column, that is here also this is x, this is maybe if I consider y, here also I have the multivalue dependency. Okay, so both side I have the multivalue dependency. So now, is it a trivial or non-trivial? Okay, both are non-trivial. Already we have seen that one. Okay, so both are non-trivial. So here we are saying is a every non-trivial multivalue dependency x to y, then x should be a super key. Okay, so here I am considering a e name. So e name, whatever we are considering, this is my x. Is it a super key? No. Okay, why? Because in this table, these three attributes together is a my candidate key or primary key also. Okay, so only one candidate key is there, that is only where selected as a primary key. So this is only will become as a super key, this entire three attributes together. But now here x is only employee name. Okay, so here this is not a super key, so this violates the 4NF. Okay, so that is x is not a super key, so that is violates the actually our 4NF. So what we have to do is, again we have to do the decomposition. So how we have to decompose is nothing but whatever tables are there, that we have to divide it. So multi-value dependencies we have to keep it in one different table only. Okay, so here employee name and p name we kept it in one table, and employee name and d name. Okay, so the whatever multi-value dependency is there, these two attributes together in one table, and these two attributes together in one table. Okay, that is employee name and d name, these two together one table. And in both table we will give the underline, that is both together is the my actually super key, sorry, primary key. Both together is a primary key. So here also this is a primary key. So now we have to check is it there in 4NF or not. Okay, so here this is my x, this is my y, so this is multivalue dependency is there. Okay, so now is it in 4NF or not? Any guesses? Okay, so okay, since we don't have any z combination only, okay, that is if x to y and z, okay, so here this multivalue definition, okay, this will fail. Okay, so it will just, this will come as a multivalued attribute only. Okay, so these two are here this will come as a multivalued attribute only, so only one dependency will come here, and same thing here also will come as a only one attribute, there is a multivalued. Okay, so to maintain this one, just we are underlining both and we are keeping it. So multivalue definition itself will fail, so this these two tables are there in 4NF. Okay, now we'll see. Okay, next one, that is joint dependencies. Okay, and fifth normal form. Okay, so one more name is there for fifth normal form, that is projection joined normal form. Okay, so what is joint dependency, then what is fifth normal form, that we'll see it. So till now whatever we studied, that is table is there, then we're decomposing it. Okay, so now this is the reverse of that one almost. Okay, so you have the decomposed tables. Okay, so if I did the join operation, okay, so this normally we will say join in terms of a relational algebra. Okay, so in terms of SQL is nothing but normally Cartesian product. After that, whatever primary key, foreign key concept is there, just will give the in where clause all equal. Okay, so we'll say as a primary key, key whatever we're matching, it's nothing but again join operation only. Okay, so if we did the join operation on all the uh, uh, decomposite tables, so you have to get the consistent result. So what is consistent result is nothing but you should not get any extra row, that is spurious tuple, or you should not lose any of the property also. Okay, so whatever who have in starting r, okay, that is the relation whatever will be given, so in that you should not lose any property also, and you should not get any extra tuples also. So that is my joint dependency. So here, so just we are denoting this one. So what if I have as a what is joint dependency is, if jd, that is joint dependency. Okay, so r1 r2 like that, rn we have the tables. Okay, so there is a relation is divided, r is divided into these things. Okay, so we are saying as a one small letter r, there is a one state. Okay, r. Okay, so so whenever we will do the join operation, that is star mark, it's indicates here this is a natural join. Okay, so what is natural join in relational algebra in detail we'll study it. So whenever we are doing the natural join for all the relations whatever we decompose, that is r1 r2 rn, for all the attributes. So whatever r1 has that for all the attributes, whatever r2 have for all the attributes. Okay, if you do it the natural join, that is pi of r1 for all the attributes, pi of r2 for all the attributes, so it has to come as a whatever normal consistent state r. Okay, so this is my actually joint dependency. So this when you're in normally, if you are saying as a, if I did the join operation, you have to get the consistent result only, you should not get the unwanted spurious tuples. Okay, that is my intention. Okay, this is a just representation of that one. So how this will be represented, if you know already relational algebra, it's fine. Otherwise we will study that relational algebra, then you will come to know easily this is just representation, same thing you are representing it. Okay, so in this also it will come as a two things, that is a trivial joint dependency and non-trivial joint dependency. Okay, so what is trivial non-dependence joint dependency is, okay, so here if we are saying as a r1 r2 r3. Okay, so in r we have, so we will say as a it's a trivial one if there is a ri, so means any of this one if I chosen. Okay, so is equal to r, if any of this one if I chosen, there is a ri, and in that it's completely contains the r attributes only. Okay, then we'll say as a this is a trivial one. Okay, otherwise non-trivial one. So maximum times trivial joint dependency will not be there, because if you decompose r into r1 r2 rn thing, so one of this one will not be same as that of r. Okay, so there is no meaning of decomposing only. Okay, if both are same means, if suppose r2 and r are both are same means, so what is the use of dividing this one r into different different tables? Okay, so normally in the maximum times we will not be having the trivial joint dependencies. Okay, so very rare case we will be having it, that is like if you have the different different primary sorry attributes in a primary key, to maintain that consistency state, directly will keep all primary keys attribute together in one table. Okay, and so that time our table size is not huge, so that time it will come better. So it's a very rare case. In real life it will not be there maximum time. Okay, so in real life maximum times non-trivial dependencies only will be there. Okay, now we'll see this non-additive join property. Okay, and lossless join. Okay, so both are same only, both meaning is same. So there is two names. Okay, non-additive join, that is means whenever you are doing the join operation, you should not get extra tuples, that is non-additive. Okay, and lossless, so when you are doing your join, you should not lose some of the tuples. Okay, so this is a property. This so what it says is you should not get the spurious tuples, or you should not lose the any of the after decomposition any of the tuples. Okay, this is the actually property. So in detail how to maintain this one we'll study it. Okay, for that we have the algorithm also. Okay, so now we'll study what is 5nf. Okay, so 5nf definition is, so here a relation r is in 5nf. Okay, so with respect to a set F, that is maybe functional dependency or multivalue dependency or joint dependency, if for every non-trivial joint dependencies, okay, non-trivial joint dependency GD, so R1, R2, Rn, all things in F plus, okay, so every Ri is a super key of R. Okay, so every Ri means, so whenever we'll decompose it, so here R1, R2, whatever maybe we are decomposing, so every Ri, okay, so whatever we have, there is a super key of R, whatever our super key main will be there, so in that whatever super key is there, it should be same, normally we'll say it. Okay, if any of the attribute is not there in that table, it's fine. Otherwise, if it is there, means it should be a part of our super key. Okay, so that is the meaning. Okay, so just we'll see one example. Okay, so here we have a supplier name, okay, part name and project name. Okay, so a supplier who supplies the parts for the project, okay, and these parts are related to some project. Okay, so if you saw, this is the multivalue dependency only. So from here to here multivalue dependency is there, from here to here is there. Okay, that is, so consider, if I consider as a supplier, so he supplies the parts for, he supplies the parts, okay, these are the part names, and he supplies the for a particular project also. Okay, so it's a multi-value dependency is there. So this is nothing but, normally we'll say that it's a violation of normally 4NF. Okay, so but there is a one more thing is there as a, so whenever we will be having the 4NF, so X, Y and Z, so there should not be a link between these two. Okay, that is Y and Z. Okay, but here there is a link between these two, that is Y and Z link is there. Okay, that is part whichever you are using for that project, that also are related to each other. Okay, so these are the parts we are using for a particular project, so these are related to each other. Okay, so this is, these are not independent. Okay, so here this is by default, it's there in 4NF now. Okay, so now we'll see how to maintain this one in a 5NF. Okay, so what we have to do is we have to decompose this one. Okay, so whatever this multivalue dependency is there, these two are dependent on each other. So here also these two are dependent on each other, and first and third column, these two are also dependent on each other. So to our here, if we saw this joint dependency, okay, so so whenever we'll trying to decompose it, we have to make sure that, so it has to, and whenever you will perform the join operation here, so it should not get the spurious tuples. Okay, so how we have to decompose this, so all three together is my here primary key. So whenever we will decompose here, this should all should be a primary key only. So these two attributes related to each other and they are multi-valued, so here we are keeping it. So these two together is a primary key, that is supplier name and part name, and supplier and which project he is supplying the parts. Okay, so those are also related, so those two we are keeping it. And here parts name and project, those are also related, so those also you are keeping in one table. So if we performed join operation on, normal join operation on R1, R2 and R3, so obviously we'll get the same thing. Okay, so you will not get unwanted spurious tuples. And if you saw here, so that is, we had definition as a, if there is a joint dependency. Okay, so that is, okay, so here. Okay, so if there is a joint dependency R1, R2, Rn, so every Ri, okay, so that is every Ri whatever is there is a super key of R. Okay, so here if you saw, these three together we had the super key. So in this we have only two attributes, we don't have anything extra, and these two are the part of our whatever R is there. Whatever R we had, these three things R is there. So this is my Ri here, this is a super key only. So this is there in 5NF. Same thing with R2 also, this is my super key. So this is also a super key, so we don't have any problem. So all our super keys only, every Ri, that is R1, R2, R3 has the super key here. Okay, super key of R. Okay, super key of R, whatever we have here, super key of R is there. Okay, so mm, okay, so next class onwards we'll study the normalization algorithms. Okay, so how we decompose some standard procedures are there, those things we'll study it.